This is a quick reminder about how we do calculations in thermodynamics of chemical compounds and how bond energies and bond lengths are related to properties of these bonds. You want to read first length of covalent bonds. Uh, the shortest bond is in molecular hydrogen, 0.74 angstrom. Uh, they are much longer bonds, like 1.6 for hydrogen. For heavy elements, you may have bonds as long as 2 angstroms. Triple bonds are always shorter than double bonds. Single bonds are always longer than double bonds. Larger is radius of element, longer is appropriate bond. So for example, CO 121, NO 122, because nitrogen is big, same. Energy or enthalpy change, to that's energy that is required to break one molecule. So if you break H2 into atoms, you are spending that amount of kilojoules per mole. If you break chlorine molecule, you spend this and this. To break double bond, you require more energy. To break triple bond, you require more energy. The rules are same. Energies are smaller for single bonds, are smaller than for double bond than for triple bonds. We with this. This is a table showing usual bond energies or bond enthalpies, which is essentially the same for different compounds. Important bond energies are for fluorine, chlorine, bromine, iodine molecule. You see the trend, the low bond energy for FF bond, and then much higher for chlorine, and then going down with length of this separation. Again, when you are going from single to double bond, the energy is roughly twice larger, and for triple bond, roughly 3 times larger than for single bond. In reactions, you can do some calculations, very primitive calculations using these numbers. So how you do them? You take all reactant molecules, break them into atoms. So this will be sum of all bond energies, and then make your product. You'll have difference between this and this state. It can be higher energy, so that's endothermic reaction, or if heat is released, the product energy will be lower, and this is exothermic reaction. Again, this is all gen chem material. Just very simple example. Reaction hydrogen and fluorine to make hydrogen fluoride. So what we need to break, HH bond and FF bond, and these two energies. Now what we are forming two HF molecule, so we form two bonds HF. Each of them has this energy. So total delta H will be this and this. minus 2 new bond energies, and the result is negative, so reaction is exothermic. Now, the fact that the product is more energetically favorable does not mean that reaction goes this way. So, for example, if you burn ammonia in oxygen, is more favorable to make nitrogen N2 and water. Why? Because nitrogen is triple bonded with very high energy. Now, when we do burning of ammonia on platinum catalyst, we are getting nitrogen monoxide instead. And this is what we want because we want to have nitrogen compounds as a result. Energetically, it is less favorable, but kinetically, it is because of effect of catalyst.